Chapter 7, Exercise 7.63. Iron oxide reacts with carbon monoxide according to this reaction. A reaction mixture initially contains 44.86 grams of iron 3 oxide and 30.85 grams of carbon monoxide. Once the reaction has occurred as completely as possible, 1 mass of the excess reactant remains. So first step, we need to determine which reactant is the limiting reactant and which one is in excess. How do we do this? It's pretty simple. It's going to be 44.86 divided by the molar mass of iron oxide, and we get the number of moles of this reactant. And then we have 30.85 divided by the molar mass of CO. We get the number of moles of CO. If the ratio is 1 to 3, well, then we have 0 grams of excess reactant. Both reactants are consumed completely. What if the ratio is more than 3 to 1? If you have more CO, CO is in excess. If the ratio is smaller than 1 to 3, well, that means is larger than 1 to 3, then that means this iron oxide is in excess, and then we can compute the amount in excess accordingly. I also have a trick. You can simply do 44.86 divided by the molar mass of iron oxide, and then you use 30.85 divided by 3 times the molar mass of CO, and then you can see which one is larger. So over here, I'm looking at this 3CO as C3O3, alright, or whatever you want to look at this. The molar mass of this whole thing is 3 times the molar mass of CO. So I'm going to show you how to do this calculation. First, 44.86 divided by 2 iron. Each iron is 55.85 from the periodic table, and we have 3 oxygen atoms, 3 times 16. Now I get 0.28 moles. Just remember this number, or I just put this number here, 0.28, just in case I forget this number. Now CO, we have 30.85 divided by okay, now over here I'm gonna have this 1 carbon and 1 oxygen, and then divided by 3. Alright, so what number I get is 0.367. Alright, certainly this is a larger number. 0.367 is greater than 0.28. Alright, so maybe I need the previous number. Alright, I'm going to use this number minus the previous number. The previous number is this. It comes from the mass of iron oxide divided by the molar mass of iron 2 oxide. Iron 2. This is iron 3. Iron 3 oxide. 2 times 55.85. That's the molar mass of iron, and then we have 3 oxygen. So we take the difference. Now we get a number 0.0863. And what is this number? This number is, okay, here. This number is the number of moles of 3CO. Alright, so I'm pretending this is carbon 3, oxygen 3. Well, it does not exist, but just for the convenience of calculation, I am looking at this as carbon 3, oxygen 3 molecule. And what's the molar mass of this? Well, the molar mass is this. Alright, if you have carbon 3, oxygen 3, the molar mass is 12 plus 16 times 3. And now I should be able to get the final answer, which is 7.25 grams. Alright, 7.25 grams, and submit. Of course, there's a more standard way of doing this. If you look at the mastering chemistry.com solution, it's a bit more standard. All right. They actually computed the amount of iron given the amount of iron oxide. They computed the amount of iron given the number of moles of CO. This is a smaller number, so iron oxide, or you can say iron 3 oxide, is the limiting reactant. And then they computed the number of moles of CO reacted, and then multiplied by its molar mass over here. They got the amount of CO that's consumed. So when they use the number of grams of this iron 3 oxide divided by the molar mass of iron oxide, they get the number of moles. And then they have 1:3 ratio. They get the number of moles of CO multiplied by the molar mass of CO. They get the grams of CO that's consumed in the reaction. And 30.85 is provided more than 23.60. They take difference, they get 3.25. So the same answer as I got here. But if you look at my calculation, well, I think it's more convenient. This is just a one-line calculation. I don't know, it's up to you. Whatever method works for you.